The first step in solving an inequality is to write it in the standard form, that is, to write it in such a way that right hand side is 0. If you look at our example, we have x cubed greater than x. It is not in the standard form, so before we'll attempt to solve it, we'll write it in a standard form. Subtracting x from both sides will give me x cubed minus x greater than 0. Now that the inequality is in a standard form, I can identify it. The left-hand side is a polynomial, so it is a polynomial inequality. To solve this inequality, we'll use the property of polynomials that says that the graph of a polynomial is above x-axis or below x-axis between its zeros. So the signs of the polynomial are determined by the zeros. So the second step will be to find those zeros, those x-intercepts. So find the zeros of the polynomial. That means I need to solve the equation x cubed minus x equals 0. This polynomial can be factored, so we'll factor x and we'll have x squared minus 1 equals 0. Using 0 property, we'll get x equals 0 from the first factor, or x squared minus 1 equals 0 from the second factor, which can be solved by adding 1 to both sides and taking the square root. And therefore we'll get x equal plus or minus square root of 1 or 1. So the zeros are 0, 1 and negative 1. The step 3 is to draw the number line to plot the points, the zeros on the number line, to see how those zeros are positioned in the right order from the smallest to the largest. Once we have the zeros, we are ready to determine the sign of the polynomial x cubed minus x in each of the intervals obtained by using the zeros as the dividing points. So in each interval, we'll choose a test point. So for example, in the interval from minus infinity to negative 1, we can choose a test point which is negative 2. Between negative 1 and 0, we can choose negative 1/2. For interval from 0 to 1, we can choose 1/2. And for interval from 1 to infinity, we can choose, let's say, 2. Now we compute the value of the polynomial or left-hand side at each point. So at negative 2, we'll have negative 2 cubed minus 2, which will result in negative 6. The value is negative, less than 0, therefore the sign of the polynomial is going to be negative in the whole interval from minus infinity to negative 1. When x is negative 1/2, the value is going to be 0.375, which is positive, and therefore the sign in this interval is going to be positive. For 1/2, the value is going to be negative 0.375, which is negative, and therefore the value of the polynomial in the interval 0 and 1 is going to be negative. And for 2, the value is going to be 6. It's positive, so the value of the polynomial is going to be positive. What we made in step 3 is the sign chart for the polynomial x cubed minus x. Now, once we have the sign chart, we are ready to write the solution. So what I want is I want x cubed minus x to be greater than 0. This was our original inequality in the standard form. So if something is greater than 0, then that something is positive, and therefore on the sign chart I'm looking for the intervals that have a plus sign on it, and this is the interval from -1 to 0 and from 1 to infinity. The points 1 and 0 and -1 will not be included because at those points the polynomial is exactly equal 0. Therefore, my solution is x cubed minus x is greater than 0 if x is in the interval from -1 to 0, union, since we have another interval from 1 to plus infinity.